1800s, Scottish physicist James Clerk Maxwell published a set of 4 equations, which set the foundation for classical electromagnetism. Even in their simplest form, they describe the reason why you can hear my voice right now. His last 2 laws, individually known as Faraday's law and Ampere's law, state the following. A change in magnetic flux over time can induce an electric field, and therefore, an electric current can generate a magnetic field. And now, I will telling how its principle working in this application. The loudspeaker and microphone were both invented well over a century ago, and their basic design has changed very little since then, though may look different today. Our transducer, which means they change one energy type into another. A microphone transfers sound energy into electricity, meanwhile, a loudspeaker transfers electricity into sound. Let's have a look at the simple loudspeaker first. At the heart of the loudspeaker is annular permanent magnet, not the shape that you are used to see. Annular magnets are not bar but ring-shaped. In a bar magnet, the ends of the magnet have opposite poles, but in the annular magnet, the central core has the opposite pole to the cylinder surrounding. These are the main parts of a loudspeaker. A cardboard cone called a diaphragm is connected to a tube with a wire coil wound around it. You may recognize this as a solenoid. The wires carry the oscillating AC input. The coil fits snugly into the circular cavity of the magnet. This is the rest position when assembled with no input signal. The loudspeaker works by the motor effect. When the current flows in the solenoid, its magnetic field interacts with the permanent magnet. Depending on the direction of the current, the solenoid and the diaphragm with it are either pushed out or poured into the annular magnet. This creates a compression wave moving with the same frequency as the input electrical signal, spread out as a longitudinal sound wave. The output frequency matches the input AC signal, and the loudness or volumes depends on the magnitude of the voltage of that signal. Higher voltages cause a larger motor effect. Headphones or earbuds are just a small version of this design. They are in the same principle of this theory. Magnets are used to produce a permanent magnetic field that attracts and repels the electrically charged diaphragm or the conductor that is controlling the diaphragm. Now, let's see an example. First, the wire is connected to the source. Then, electric current flow through the red wire into the coil and flow to the blue wire. After that, the coil will be magnetized and create a magnetic field around the coil. This magnet has same polarity as a permanent magnet, and it's gonna repel against each other. If the current passes from the blue wire to the red wire, this will create a magnet that opposite to the previous magnet. By changing the polarity, the magnet will attract each other. These are the processes that happen inside the headphone. There is a diaphragm that helps to properly react when the electrical current is passed through the conductors. Once the electrical current passes through the conductors, the polarity started to change, and the diaphragm interacts with the permanent magnets, and this will cause it to vibrate and producing sound. The magnetic causes the diaphragm moving from left to the right, and the vibration will create the sound wave. Current will change the direction, thus making the magnet to repel. It forcing the diaphragm to move to the left and creating another sound. That's all from me to show how this application works. In essence, headphones work by converting varying electrical currents into vibrations that produce sound. Unfortunately, many people use headphones on a daily basis, but only few actually understand how they work. Thank you. Bye.